I'm going to go ahead and review how to potentially get a structural equation model complete using social listening data. So I'm going to give you kind of a quick background on social listening data, quick background on structural equation modeling, and I'm going to try to get this video done in about 15 to 20 minutes. All right. If you need more details, feel free to send me an email at ronald.coyle3@gmail.com. So again, that's ronald.coyle, the number 3 @gmail.com. You can also find me on X, and I'll go ahead and show my account towards the end here so you can access or send me a message if you need to. All right, so without further ado, let me get into this real fast. So, social listening data. By the way, if I mention anything, I have a lot of the content necessary for this cited on a report using social listening data to build a structural equation model. So if I mention certain things, I have a lot of content cited in here already. I'll reference this document. I've done a little bit of literature review, not extensive. There's certainly a lot more I can use when I get into indicator and latent variables. You'll kind of see that since this is more of a feasibility study, like can I actually use social listening data? I didn't put as much time into that kind of research just because I could go down a rabbit hole with that and not get anywhere with it, and then ultimately to just be left with a question mark. So this is kind of a very high level, hey, can I even do this at all? So there'll be certainly some limitations, some things you'll probably go, wow, why are we doing this? Or that's different. And that's totally fine. I think I'm just trying to get the conversation started. I've only seen one or two projects maybe even mentioned at using this data. I haven't really seen videos or anything on how they were able to do this. So again, if I have something in particular, I'll certainly reference this document. I'm hoping to I have it available for a preprint on ResearchGate right now. I've gotten some decent viewership on as far as the interest scores and everything on that site for this and some other information that I've had. Oops, it's gonna kick me out of there for some reason, server error. So, but again, it is available for review. I'm trying to get an actual publish as well, so more to come on that. Okay, so a little background, social listening data. It's been around for a number of years. This is a study I did while working as a civilian on Fort Carson. This is all publicly available information, so nothing here that I'm sharing. I just want to show you the big things. So you can access thousands of messages on social media. I only have around 200 for this one, as random as possible for this particular study. I was just looking at what people were saying about Fort Carson. I am prior military, but I was working in a civilian capacity. Again, all publicly available information. I wouldn't share anything that would be inappropriate otherwise if I knew about it. So I was just trying to do some stuff for a healthy living concept on the base. It was geared towards civilians living on the post as well as active duty soldiers. So brought in around 200 messages. I did not use any real software like Sprinkler, HubSpot, TalkWalker. Some of those can cost thousands of dollars into the six figures. I spent pretty much just 2 weeks of using some elbow grease and collecting the data myself. I'm just pretty good at getting it. What I did is I went out, got messages on Fort Carson from Reddit, Twitter, TikTok, X, or now Twitter again, Instagram, certain blog posts, other discussion forums, and just aggregated them into a spreadsheet. I tracked things such as gender, so I really looked at people's profiles. If I saw who they were posting, were they active, were they service members, active duty, reserve, guard, drill, on drill, were they civilians, so spouses maybe. Aggregated everything, ran it through a word cloud, just the messages, wanted to see what some high level things were. I collected the dates, so if I saw the post, I got the date that I saw it posted on, so I could trend out the information. This type of stuff's been around since 2000 and early 2000s. When I got out of college, I had a job with a company called IntelliSeek. It was a startup, and they did a lot of data mining. They had proprietary software, brought in a lot more messages, but even then, that wasn't perfect. Even if I've had access to Sprinkler or proprietary software in the past, I've usually supplemented it with my own searches. Sometimes certain data just isn't available. For instance, I can't go to YouTube and scrape a lot of the comments. Same thing with blogs. That's where a lot of the good stuff is, not just the blog post itself, but if the blog has really good viewership and people are going in and hitting comments. A lot of times these platforms can't data mine that. Even going back as far as 2019, Sprinkler was not able to get the comments. So I still went in and supplemented even with the comments, because that's where the good discussion's at, when people comment on a blog post, not just what the original author said. So again, you kind of see it's pretty versatile. I'm able to get sentiment. So is the discussion more positive or negative? So that's just kind of an overview of social media data. I can get into the nitty gritty. Again, gender, break out what topics people are talking about. In the instance of Fort Carson, a lot of it was, hey, I'm getting stationed at the base. I need housing. Can you help me with that? So just give you kind of a quick overview. So social media data is pretty versatile. All right, structural equation models, a little different. All right, so for this, I'm going to reference a abridged version of my dissertation. It's available for publish in the Journal of Social Media. So this here, I used a Likert scale for this, and I did a lot of extensive research. Again, not for this particular study, the exploratory one I'm talking about, using social listening data, but for my dissertation, I didn't get that fancy for it. I just wanted to get my doctorate degree done, so I kept it pretty straightforward. Used a traditional survey. I built out a model using a Likert scale. So what I had here was latent variables, and I'm guessing if you're looking at this video, you're probably already looking at information around structural equation models. If not, that's probably a step or two beyond what you might be interested in. So these are my latent variables: brand awareness, informativeness, entertainment, credibility of advertising, social media marketing value. A moderator would have been annoyance, irritation. And then overall, I wanted to see what the impact of the model was on purchase intention, and then just brand awareness on purchase attention or intention. All right. I think I had like a sample size of 400. Well, the cool thing with surveys is one person can answer all these questions. So I had basically 400 people answering all of these questions. This is the main Likert scale questions that I asked. I would have had one question which to help build out as an indicator for, say, brand awareness. Social media is effective in creating awareness of brands. 7, yes, very likely. 1, very unlikely, or least unlikely. So however you want to set up your Likert scale. So it was a 1 to 7 Likert scale, though. So each of these questions would have been used to help build out my latent variables. These were my indicators. All right, so social media data is a little different because I can't have one person answer all of these. I might be lucky if I find a post where someone maybe addresses maybe one topic, and then I'll have to find someone else to address that topic and then that topic. So totally different animal that we're talking about here. So again, so let me kind of give you a quick run through of what I mean by that. So for this particular study, what I did is I created a spreadsheet, and I had basically a column here where I would have the message. I could have copied it over. I have an overall polarity score. Now, I got that using some Python code. So if you're familiar with Python, they have a cool little feature called text blob, and I'll kind of go over that here in a second. Now, these are sort of like the equivalent questions if I was using a survey, except one person's not going to answer all these. I'm going to have a ton of unanswered or blank data here that I would have to kind of guess what someone might have input. So, for instance, park prices, I would have went out, and you can data mine this using social media. For this particular project, I'm actually just using a sample set of data generated through ChatGPT. Reason being, time and money. It's totally free for me to use it, and it's very easy. I can literally get a set of data coming back to me within seconds. So again, I just wanted to see the feasibility. I'm just kind of playing around with this, where it goes from a scientific standpoint or market research standpoint within social media is totally up for grabs right now. But so brand park prices, I'm just looking for mentions of people saying, hey, the park prices are too high, too low, just right. Brand park mentions, are they going to mention Disneyland, Disney World, Animal Kingdom, all the big parks for Disney? Characters, I can go down a rabbit hole with this. I'm just sticking with the basic ones: Mickey, Minnie, Donald Duck, Goofy. Most people know them. Corporate finances, what do people feel is the big ahas? Like, do they feel Disney's still profitable? Creative strategy, what do they feel about people maybe delving into live action versus maybe sticking with the the original classics. DI, diversity, equity, inclusion. So Disney as related to, say, LGBTQ topics. This would have been corporate image as far as latent variable. This one would have been brand perception. Over here, I have experiences away from the parks. Again, I didn't put a lot of literature research. Some of these I just kind of used maybe some hunches on this. Certainly an area I'll probably want to improve upon moving forward. Again, reason being, I just want to see if I can get a model build. I could spend all day looking at the perfect ones, and then just because I'm going to have so much missing data, I may have spent a lot of time on unnecessary research at the moment. I'm not saying there's not a need for it. In my dissertation, I definitely went and did the homework on the literature review. This one I just kind of did a high level. Most journals want to keep everything to about 30 pages, and I wanted to focus a little bit more on other aspects. So again, quick run through. Just want to see, is this even possible? So experience away from parks. Obviously people can not go to Disney, but they'll still see Disney movies, watch Disney Plus, maybe see Disney on Ice. So experience away from the parks. So kind of give you a quick rundown. Went out to ChatGPT. I use a variety of different queries. For instance, create what can be considered 100 sample tweets that can be found on the social media platform X that pertain to, say, Disney on Ice. And I would basically just switch these out. One would say that pertain to Disney characters, and I could get a little detailed, such as Mickey Mouse, Goofy, Donald Duck. The more detail I put in there, the better. Brand parks that mention parks, Disney parks. And then once I got back kind of a sample of 100, I went ahead and just pulled 30 random, so a couple from each of these. Again, just trying to get a flavor for what's out there. These should be posted on what ChatGPT is seeing as a reflection of what you might see on X. All right. So once I copied the message over, usually didn't take in the emojis or anything. I ran over to Python, and I'm using Anaconda and on Jupyter, basically, if you're familiar with that. This is sort of the code, so you can see it. I'm not trying to hide anything here. It's not proprietary knowledge. I did have to do a quick conversion, so once I got the score, because Python gives you a score of -1 to +1. -1 being most negative, +1 being most positive. That's a scale, that's a range of 20, not 7. So I did have to convert that. So if a message would say greater or less than 0.08, then that would be 1. If it was between, say, -0.05 and 0.0799, then it would be a 2. So as it got closer to 0, it got a little more positive. Numbers hanging around 0, slightly better. And then anything basically above a 0.7, according to the Python score, would get 6 or 7. So you can kind of see the breakout right here. All right, so once I input this message, and again, these are one-liners. If I had larger blog posts, I would have to go through and data cleanse this. For instance, if I just had 50 lines, I would literally have to write +/ add in the next line, +/ add in the next line, +/ add in the next line. It can get kind of tedious. That's why I just did a quick test run using this. So once I run this initial code, it would basically come back, give me a score. This one, for instance, would say 0.0. All right, so I would write 0.0 because I'm asking it to return what it's telling me. Then I would input it, and then it would give me the math. So I'm going to input that, and then, 0.0. And then it will tell me that's basically a 4, which right here, less than 0.1, but greater than -0.2, so 4. So lines right up. So then I could just take that message over to my spreadsheet. I could write that message in for Disney on Ice. And again, I would do this for pretty much all the messages. I try to get about 30 per topic here, at least to go. This is more of an official study. Certainly I could spend more time on it. Again, I just want to see if it was even official. So forth. All right, couple caveats. TextBlob, I did not build this, so I don't know its entire natural language processing abilities, what in the dictionary might it consider positive, negative. It does a pretty good job overall. There's certainly messages where maybe it came back extremely positive 7, and I'm like, nah, that could be 5 or 6. I kept the score because I figured I'll win some and I'll lose some. There's some that came back more negative, and I thought it could have been positive. So, for instance, if someone said, "Just got Disney on Ice," that was bad. Well, I'm from the 1980s. Like if I said something was bad, that's cool, that's good. That could be positive. So, again, there are some limitations with using text analysis. But sky's the pie. If this starts to work, you can maybe convert video to text. Call centers already do this. They can capture your recordings of conversations, and then they can convert those to text files. Now you can start running the text files through the stuff and really building out some interesting findings. So again, just kind of dabbling in this right now. So all right, so essentially what I did is I ran through and got 30. We can debate sample size later. I'm just trying to keep this the bare minimum that I think I need based on my current knowledge of statistics. I'm not a statistics major, but I have some statistics background. So normal bell curves, random sample of 30, that was the minimum. So I kind of just went with that, and then based on some prior research, I needed at least 30 per indicator. So did a couple of things here. I looked at, I had a ton of missing values. Again, anything in yellow would have been missing. So for like the first 30 that I was looking at, basically, I went ahead and input the actual score, the polarity score that I got back from Python, that again, between -1 and 1. I had to fill in there, kind of figure out ways to get this. I could have used mean substitution. That one wasn't really the best. So I started off with ran between, and I just gave and assigned one between 1 and 7. I eventually exported just that. I didn't quite get the reliability that I was looking for. I went back and I looked at kind of mean and median. So these both pretty much fell in 4 within this one. So what I did is I went ahead and kept this between 3 and 5 pretty much for each of the topics. So kind of fell between 4 and 5 for everything. So I just used a ran between and kept it closer to what was coming back. So what I'm trying to do is guess what would the person actually have input for these. All right. Then I came back and did kind of something called a random one up, one down. So an equivalent to this would be something called K&N, or K nearest neighbor. Again, if I mentioned anything that seems a little off, let me know. It's kind of a huge test run on this. But there is a concept called K nearest neighbor when you're trying to do data imputation. So K&N study uses one example, K&N, basically where you're looking at swapping things in close proximity from what a response would have been. Typically, if it's a survey, you're not going to have this many missing values. Maybe somebody answered all these questions and maybe they forgot that one. So you're trying to get a lot of different things here. After that, I did something called multiple data imputation, which basically I just took the random, the +1, +2, and then the K&N, and I just averaged them out and just ran with that. Now, as far as ways to impute data, there isn't really too many set ways to do it. There's definitely some very complex ones. I'm not going to go down that rabbit hole. Probably need to do a little bit more learning on Python, see what I can do. But you can do something called multivariate imputation through chain equations. Need some Python code for that. I did a couple of the more simple ones. So there's certainly some ways to get very complex. This is probably what I would say middle of the track way that I did here. All right. So once I did that, I pretty much just copied over the average one into a separate spreadsheet. I had to save it as a CSV file, and then from there I went over to Smart PLS and I imported the data. All right, so just to kind of give you a couple run-throughs on this, when I looked at the data, I wasn't getting quite the results. So I think one version of this study I utilized, hold on, random data replace. That would have been equals ran between basically. And my factor loadings, typically you want factor loadings to be above 0.5. And for this one, it's so new. I kind of wanted to hold myself to a standard of above 0.7. So most of these weren't really falling within the range. Also, just in general, kurtosis, typically want that to be ±2. So I got a little better with random replacement. It wasn't as optimal as I would have liked it, but I definitely got better with random replacement versus just a mean swap, so mean substitution only. For this one, I definitely had some very high kurtosis, plus outside the ±2 range, 6.1, 5.7. So that one just was not doing the trick. Random got a little better. Um, and then the one where I used the MDI probably was one of the better ones that I saw. Although I did still have a couple of issues with discriminant validity. So ultimately, what I did is I had to pare this model down. So I had an initial hypothesis run through where my proposed model was going to look at these topics. So I had three indicators for each of these latent variables. So experiences away from Disney, corporate. I want to see what how they impacted brand perception. Again, my main thing, could I even run a model on any of these? I wasn't exactly using, again, a lot of background research to build out these latent variables. So certainly some things I need to improve upon on that end. But again, I could spend all day on it. Just want to see, could I even get this done super fast? And what was the likelihood of that? Here's kind of some basic AI prompts that I use for that. So I try to be pretty open. We can discuss sample sizes later. Again, once I kind of fine tune things, then maybe I can start looking at larger sample sizes, getting some better data collected, maybe use real world data. There's so many places I can go with this. I just want to see, can I even run it? So here's the code. So everything you've seen, I'm just trying to be open for, because my goal is just to open up a conversation about how to use social listening data for this, or text in general. Again, had to do something called data imputation. So replace it with random values, did mean substitution, multiple data imputation. So I had to fill in, kind of guess what would a person would have filled in. So survey respondent number 1 would have been this line, then this line for 2, then this line for third, fourth respondent, fifth respondent. I had to do that basically for 30 per topics. I think I still had over 200 altogether, but it wasn't one person answering each question. All right, so let me kind of go over what I ended up with here. So I looked at the factor loadings, and I think what I ended up doing here is going with a very simple model where I looked at hypothesis 4 kind of as a standalone. So this would have been a breakout of my indicator. So when I say corporate image 2, that's creative strategy. If I say experience from away from parks 1, that would have been movies, and then experiences using Disney Plus. And the focus came back with the factor loading. It worked best when I looked just at, I think it was 1 or 2 of the indicators from experience away from parks and its impact on corporate. I didn't really get the findings I wanted from the other avenues looking at their impact on brand perception. That could be certainly faulty due to the methodology, the fact that I didn't pick the best indicators to build out brand perception. So well aware of the limitations of this. Again, can I just build a model? I think that's goal number 1. But did require me to kind of go through and look at the data from different angles. I ended up going with experiences away from Disney, just looking at corporate. And I did ultimately have to go with at least one indicator. Not ideal, but it's certainly not outside the realm. It's certainly possible when you're using Smart PLS. And again, I have that cited within the report as well. So when I went out to Smart PLS, this is sort of the model that I got. So VIF, so a lot of these came back green. Everything's pretty good to go there. And the report, I kind of go over what the bare bones sort of metrics are, and I even have them listed out in my appendix. So a lot of the things, once you kind of get good at this, like for instance, composite reliability should be greater than 7, AVE should be greater than 5, discriminant validity 0.85 to 0.90, less than that. Path coefficients, p-value, I want that to be less than 5. So this is sort of a quick breakout. No, I don't report on each and everything. There's a lot of things I am well aware of the limitations here. So what I ended up with is a pretty simple model here where it looks like I had roughly 13% of the variance explained. Overall, the predictor had a minimal effect, so it wasn't super strong, but it was statistically significant. Again, there's so many more things I need to really look at for this methodology. So I was able to get a workable model. So again, we kind of run you through Smart PLS here. So you had to, basically I had to go through, I used Disney movies and Disney Plus. So these were my 2 variables. I'm sure, again, if you're watching this video, you probably use Smart PLS at least a little bit. Corporate image, I just went with corporate creative strategy. That seemed to be the one that I ended up going with. And then from there, I I went ahead and calculated everything. So I have again 0.134. That's my R squared. My R squared adjusted was 0.131. This is my path coefficient 0.366. Factor loading. So these are above 7. So these are pretty solid here. Now that one's a little iffy, but it's the only one. So of course it's going to be a little bit higher. It's a 1 overall. I did get some other factor loadings that were a little better, but this seemed to be the best. I just kept a very simple model. Not ideal to go with 1, but that's the best of the best. So that I could pull out right now with this one. All right, so when I started looking at some of the other data within this particular study, then I was able to go through and calculate that. I think I did do a bootstrap as well at one point. So I just wanted to run through some basic information here. So again, path coefficients, general effects. Let me see. Outer loadings were good. Again, above 7. So that's what I was looking for there. Those are the overall latent variables. So again, I just went with a very simple model on this one. Let's see here. So composite reliability was pretty good. I didn't really go too much off Cronbach's alpha. AVE was pretty good. So definitely got a few things I need to take a look at in terms of Cronbach's alpha. And some of the stuff I just need to do a quick refresher. It's been about a year and a half since I did my dissertation. So I do know I want to go back and take a look at the information. Again, I didn't look at this in terms of were these the best indicators. I was more or less looking at this from the standpoint of, can I use this type of methodology at all just to build a structural equation model at the moment? I can fine tune the actual information once I do some more literature research, find a topic I really want to go down and this rabbit hole and look at and spend that kind of time on it. Discriminant validity came back pretty solid there. Again, nothing red. VIF looking pretty good there. Variable inflation factors. So everything kind of checked out. Again, not a super strong model by any stretch, but it did give me some basic overviews of things that I was looking for to see within a model itself. Let me see if there's anything else I wanted to run here. So yeah, that was the main thing. Again, let me bring up the report again. So yeah, so again, 0.366, that was supported. And then t-square p-value less than 0.5, so that would have been statistically significant. T-score was greater than 1.96. I think that came in at 3.747. So what you have here is a very basic model. Again, the methodology certainly needs some fine-tuning, and I'm not the smartest person around to try to figure out everything. I'm just taking some stuff that I learned in the real world, stuff I learned in academia, and I just wanted to see if I could merge these two, because sky's really the pie on this, in my opinion. Let me see if there's one source, and I'll need to see if I can find it, but they do a pretty good job of actually, it looks like they built an actual model similar to this one. They came out with theirs a little bit after I came up with my idea. Mine, I have a feature on ResearchGate that I pushed out, not official published, but it was January 23, largely because most places wanted me to do an actual study with quantitative metrics, which is why I did this one. So this one hasn't really been published yet, but I did come up with a proposal. And then I actually cite my dissertation because I came up with this in my dissertation, which actually got published in May 2022. Just the idea of using social media data for structural equation modeling. So I'm certainly one of the first to come up with this, but I did find another one, social listening found one other. Yeah, this one here is pretty good. It's from Chen and Butte, and it looks like they were able to. They haven't been cited or anything, but they definitely use social media information to help build a structural equation model. This one's more medical. This one was published, it looks like in April 2024. They don't have a video. It's more dealing with COVID. I really would have to go in and look at their methodology. So it's probably a little more advanced than mine. Medical students, they're definitely on top of a lot of things, pretty forward thinking. But that being said, I certainly, let me see here, because that was 2024. But as far as, here's my actual dissertation. And you can go right out to ProQuest and look this up. Let me see if I can. And this is published in the Library of Congress. Let me go to recommendations. Whoops. Might be nice if I have that. Recommendations, and then so basically using this to build out a social structural equation model using social media data. So, all right, hopefully that sums up everything for this. But yeah, it's pretty interesting where you can go with this future research. So basically just using social media data to build out structural equation models. So, all right, let me know if you have any further questions.